The title of my talk is The Power of Datomic, and I'll introduce you to the design concepts of Datomic. I'll show you some examples, and hopefully by the end of my talk you'll find Datomic as amazing as I do. Datomic is a new database system that simplifies database architecture into independent components like storage, reading, writes, and queries. And because they are separate and they place nicely between each other, we can create amazing things with them. Okay. Because Datomic is different from SQL's or non-SQL databases, I thought that it would be really nice to see the main features of Datomic. So in Datomic, there's no update in place. So whenever you add new facts, they are not erased. You just mark them as not valid anymore, but they stay. So Datomic supports assertions and retractions, but retractions are not removals unless you've got some legal reasons to remove. Datomic supports this feature. Datomic is an immutable database, and Datomic provides itself as a value that can be used in our queries. Datomic has got flexible schema that is less rigid than SQL schema, but more structured than a schema in, for example, MongoDB. Datomic supports ACID transactions, and Datomic uses declarative and logic for queries. Datomic was created by Rich Hickey, the same person who created Clojure. That's why it shares the same philosophy as Clojure and that same reality model. So I would like to briefly mention how Clojure and Datomic think about value, identity, state, and also time. So value, it's a never-changing property. It's stable and immutable. An example of value would be number 44 or string John. And it wouldn't make a sense to say that number 44 equals 61. They are different. And value has got the same meaning regardless of context. So 44 orders or 44 customers, they all use value 44, although in different context. An identity, it's a named entity in a system. It can have different values at different points in time. So we might have a person called Johnny, John. His mother might call him Johnny, and when he plays games, he'll be known as Elfenlied. A state, it's a value of an identity at a point in time, and time, it's a byproduct of ordering states within an entity, so we can think about time in linear way. So in the morning, John is known as Elfenlied. In the afternoon at work, it's John. In the evening, again, when he plays games, he's known as Elfenlied. Okay. All databases, they've got some simple units of operations. In relational systems, it'd be table relation. In Datomic, we've got datum as a basic unit of operation. It's also called a fact, and each datum is made up of 5 parts. We've got an entity, attribute, value, transaction, and operation. So here we've got entity with entity ID of 2439. Its attribute is name. There are different values, John, Elfenlied. We've got transactions, so we can keep track of changes to entity, and operation, it's either true or false, meaning that datum was updated or not. Okay. Datomic is not only about now, but Datomic allows us easy access to past and also future states. So we can answer such questions as what was the value of X 1 week ago, or hopefully it won't happen too much, what was the state of database before it crashed. We can answer such questions in relational databases, but it's not so easy, and it's not supported as it is in Datomic, because in Datomic everything is data, and Datomic operates on data structures like lists, maps, vectors, also keywords and strings. Not surprisingly, functions also treated as data, but it might be surprising that schema is also data, and we can run queries on all data that is available to us. Okay, so talking a bit more about Datomic's architecture, Transactor is one of the components that is separated in Datomic. It handles all writes. All writes are handled by single instance of Transactor. Actually, there are two instances, and one is on the standby. So if your first instance goes down, the other one can start working immediately. Transactor is ACID compliant, and whenever your transaction is committed, a message is sent to transaction submitter and all the other applications committed to Transactor that your transaction was finished. In Datomic, all applications connected to Transactor are called peers because they're equal, and all of them, they can connect and communicate with a Transactor. Okay. Perhaps surprisingly, Datomic doesn't store facts directly, but uses existing storages like DynamoDB, RAIAC, Infinispan, or SQL storages. Datomic stores datums in segments, so they are not stored individually. And Datomic stores them in a few different ways. So we've got chronological log, and also datums are stored in various indices, and we will see shortly why storing them in various orders is beneficial. So each index is comprised of entity, attribute, value, and transaction in different orders, and there are 4 indices in Datomic. The first one, it's entity, attribute, value, and time index. It's similar to the row-like view. So here we've got a snapshot of how datums would be stored, and they are sorted by entity ID. So we've got 134 and then 586 followed by 976. This index is stored for all the datums. Another index that is created for all the datums is the attribute, entity, value, and time. It's similar to the column-like view, where first we sort by attribute and later by entity ID. The third index supported by Datomic is the AVET index. It's only created for datums that we marked as unique, and it provides really fast lookup if you want to find values. And the last index is the value, attribute, entity, time index that provides us with fast lookup for references between different attributes, because in most of the systems you'd have entities that are correlated to one another. Okay. Datomic provides to the application a view of database as if it were a value in a cache. This value is immutable. It's a graph of entities and their attributes. It's iterable, and it provides direct access to indices depending on our needs. What's even more interesting, we can pass this database value to our queries and functions. Datomic uses a flavor of Datalog to create queries. Like SQL, Datalog, it's declarative, so we specify what we want to do, not how. It is the job of query engine to figure out the most optimal way to satisfy our query. One of the killing features of Datomic is that Datalog is a logical language, so we've got such tools as pattern matching or logical variables to our disposal. Datalog's query structure is similar to SQL's. We've got different kind of clauses. So for example, there's a find clause. It's a projection clause. It's similar to select. We specify what we want to find out. We've got in clause that provides bindings, so we can parameterize queries depending on our needs. And for some type of queries, we don't have to specify the in clause because it's implicit. Although for more advanced and involving queries, we would use the in clause. And also there's a where clause that provides restriction, and most of our logic would be in the where clause. Okay, so for the following examples, I would use a simple schema with entity person. It will have an attribute of name with some values like Joseph Conrad, George Orwell. There will be also genre with type like novel or fiction. And also there'll be book entity with author, title, and genre. So one of the simplest queries that we could ask is to find out titles of all the books in our database. So we've got find title, where there's a book with book title attribute that's got some value, and here we are using symbols question mark title or question mark book. These are logical variables, and the query engine would bind appropriate entities or values in order to satisfy our query. And the bindings are implicit, so we don't have to specify them. Okay, a more advanced query would be to find titles for all the books written by Joseph Conrad. So here, again, we want to find title, where there's some book that's got an author, and this author, his name is Joseph Conrad, and finally, this book should have a title. Okay, so we could see here that book and author are repeated, and this hints to the Datalog query engine that book should resolve whenever we mention book and repeated this variable, it should resolve to the same entity. The order, this query is similar to the previous one. The order query doesn't really matter. Both queries are semantically similar. There's a small performance difference, and as a rule of thumb, we should provide the more specific datums first. Okay. Of course, in our applications, we would have more entities, and we would like to ask more questions. So here, we want to find out what's the title, author, and also year for a book, and we provide arguments and logical variables that are bind. Of course, as we can see, if we have a lot of entities, it'd be really difficult to specify in the find clause every single attribute that we want to get. Luckily, Datomic provides pull API that allows us easy access to Datums attributes by providing a number of patterns for querying. One of the data patterns that we could use is a wildcard pattern. Similar to Unix, it's a star. So here, we want to pull from our database all the attributes for some entity ID. In some cases, we want to be more specific, so this query would pull only book title and book genre for Lord Jim book. Okay. Whenever we have entities that are connected to each other, like book entity would have a book author attribute that points to some person, we specify it in our schema as db.type_ref, and we provide a name. So answering questions like what's the genre of certain book, it's quite easy. We pull all the attributes. But what if we want to find out all the fiction books in our database? We can do this using reverse lookup that navigate backwards from declared references. So here, all what we have to do is specify book genre with an underscore, and this hints to Datalog query engine that we want to navigate backwards. So whenever there is a book entity that's got some genre, we want to go the other way. And this example would find all the fiction books in our database, or the database value that we pass. Okay. For the following examples, I'll use a number of German philosophers, and we could presume that philosophers that lived later, they knew about philosophers from the past. And we will also have an attribute person influenced by. So we could say that Hegel was influenced by Kant, Leibniz, and Kepler. If we wanted to find out who influenced Kant, all what we have to do is specify the navigation, how to get. So here we are looking for person name, and our navigation is by attribute person influenced by, and we provide some value. Value 5 would mean that we want to look 5 degrees in the past. So in our little list of philosophers, we could see that Kant was influenced by Leibniz, and Leibniz himself was influenced by Kepler. Okay, so we know who influenced Kant, but what if we want to find out who was influenced by him? As it turns out, it's quite easy to answer such question by using recursion plus reverse lookup. So here again, we want to find out name of a person that was influenced by, and we use an underscore in our attribute. So we've got person slash underscore, and the answer that we would get was that Hegel was influenced by Kant and Heidegger was influenced by Hegel. Yeah. So as we have seen, Datomic provides quite a few ways to query, but it's not the end. In Datomic we can use Java queries. So here we'd like to find out name of some person, only if this name starts with capital letter M. We could also use query functions, so we are not only limited to Java methods. But we can write our own queries that allows us atomic transformations, integrity checks, or constraints. Database function, it's a simple data structure. We declare it with keyword dbfn. We can provide some documentation. At the moment, Datomic supports Clojure and Java functions. Our functions can take parameters and also reuse Clojure or Java libraries. And of course, we put some logic. So In this example, we've got getKVolume function that gets us number of books in thousands. It's a closure function that takes number of copies as its parameter. I'm reusing formatK function from some namespace, and all what it does, it just calls this formatK function with the result of dividing number of copies by thousands. Using this function is as simple as calling invoke function on database value, providing function name and parameters, and we get results. This is more involving function that we can use for validation, although it's similar to the previous one. We declare function name. We say that it's a closure function that takes book parameter. We need some functions from the closure namespace, and in our code I stated a book needs title and an author, and if one of them is missing, I throw runtime exception, otherwise I return a book. We can use our validation function in our validate and construct function. So here in the parameters we pass database and also map. I'm using database in order to get our validation book function. I saw it as validate, and then I'm passing book to validate function. Should be pretty straightforward. And using our validate and construct function is as simple as calling it and passing map or book that I want to transact. Okay, so in previous examples we've used database value that allows us access to whole database loaded lazily, but sometimes we don't want access to all the datums in our database. We want to filter them, and Datomic provides us with a number of filters to filter a database based on some predicate. Whenever we want to get only relevant datums. In Datomic there's a number of built-in filters, and we also can create our own filters. And using filters allows us to pass database value to our queries or functions. So one of the built-in database filters is as of, that returns database value as of particular point in time, ignoring any transactions after that point in time. We can specify this point in time either by using transaction ID or an instance of java.util_date, or something what's called time basis of database. Whenever you add a new transaction and datums, Datomic would increment its own time base. So using as of, we can answer such question as what was the value of database last week, last month, or even last year. And using as of is really simple. So if we have function called find population that accepts a database, we get the value of as of by using as of function, passing some database that we want to filter, and time. In this case I'm storing time for transaction associated with Berlin 1850. Since is another filter built in the Datomic. It's opposite of as of. Since returns the value of database that includes only datums added after a certain point in time. It's quite useful for auditing or answering such questions as what were the transactions after a certain point in time, and similar to previous example, getting the value filtered by since is as simple as calling since method, passing database that we want to filter, and time. And in this example, we can get latest changes. So again, we use since filter. We are using Datums method that accepts keyword, and we pass index, so we can get really fast lookup because we are interested in entities that were added since 25th of December. Okay, so in previous examples, we looked at database at certain point in time, but with history, we can get history of datums or group of datums. So if we were adding population of Berlin from medieval ages to now, and we want to track this progress, we would use history to answer such questions. In this code snippet, I'm calling the history method, passing database. The Datalog query would return me attributes names with values and also instance of time. I'm filtering because I'm only interested in populations, and I'm sorting on the population. So depending on data on my database, I'll get such results as city population 260 and so forth. Sometimes things go wrong, and we've got database with data that we don't really want. Datomic allows us to create custom filters where we can filter incorrect datums or data that is not applicable after a certain point in time, or we want to filter data because of some security reasons. So this transaction would add wrong population for Berlin. So we know what's the transaction ID associated with this transaction, and we can store it. And here we create our correct filter that will basically check if transaction associated with certain datum is in our list of wrong transactions. And we can use this filter to get corrected databases. Having this corrected database, we can use it in different queries and get list of datums without our wrong transaction. Finish a bit earlier than I expected. I hope so that I introduced you to Datomic, but there's so much more to Datomic that I could cover in a short talk. For example, you can use negation in queries. You can, I didn't show you any examples of retraction, but they are possible. Also, you can use excision, that is true removal. Datomic supports partitioning at the logical and also physical level. The with function allows us to stipulate what would the database look like if we add some data, so we can run some queries as if we had database 1 week ahead or 1 month ahead. And also each topic that I've mentioned could be covered in a bit more details. So if you'd like to learn more about Datomic, here are some links to really interesting resources. Okay. If you got any questions, you can send me a message or on Twitter or on my email, and that's a link to slides if you like to go through them in your own pace. Okay, thank you.
Questions?
Hi, do you have experience introducing Datomic to engineers that have mainly SQL experience? I mean, people who are not necessarily coming from the Clojure world. So introducing Datomic into an organization just for having the powerful query language, for example. What's your experience with that?
Unfortunately not, I don't have such experience. At my work we still use Oracle database. I would really love to use Datomic because I know that it will simplify our development and answer such questions, because quite often our application crash and then we don't know why it happened. So I believe that if I can convince management to use Datomic, it would be really nice. And Datomic is not a big step forward from SQL. If you know SQL, it's quite easy to transition to Datomic.
Since Datomic is a commercial database, can you tell us how much can you do with the community edition? And I think that it has some free quota. And the second question, does Datomic provide any features that, for example, allows like fast queries such that you don't have to use Solr or I don't know, for some stuff like Elasticsearch? Although you use mainly Elasticsearch for text search, but for other stuff, like when you need fast stuff. So that's my question.
Okay, so to answer your second question, not really, because Datomic treats values as data, so it needs to load all database, although it's loaded lazily. Datomic is not really good for things where you would use Elasticsearch, because you want to work across your data on aggregates. So for such reasons, Datomic is not really good. The main killing feature for Datomic is that you don't have updates, so you can always go back in time, go back in future. You load your data lazily, so you've got access to Datums. But if you want to load all of them at once, you would crash your app. So it's not the best use case for Datomic. And as you said, Datomic is a commercial product. It's not open sourced. You can download Developer Edition, where you can experiment with it, and it uses memory database. It's free of charge. Another free of charge option is the Datomic Pro Starter, and it allows you to connect to SQL's storages or infinite span. It's free of charge if you experiment with it. And also for open source project is free of charge. For commercial products, you would have to buy a license, and Datomic's website provides information what are the charges, and you are charged for transactors and other processes that you use.
So if I understand you correctly, Datomic can run on top of React. and other NoSQL databases. So, do you also get the benefits of a distributed database when using Datomic in terms of resilience and lack of a single point of failure?
Yes, so as I mentioned, Datomic doesn't store data itself. It uses those storages like SQL storages or Bryac for storing data. So Datomic is like a layer that provides us to access to data and work with it. Because reads, writes, and carries are separate, they are separate components, you can scale them in different ways. So reads, they scale a lot because each application has got access to database in memory. It's cached, it's immutable, so it can be cached. So your iPhone application can work with one database value, and your Android application can work with another database value. So they can scale, so reading can scale horizontally. In terms of writes, there's one transaction working at one time, so you could think about this as a single point of failure, because there's a certain amount of transactions that can be processed by one transactor at a certain point in time. Having said that, Datomic is used by banks and different institutions, like New Bank in Brazil. They use Datomic on top of DynamoDB. They're quite heavy as far as I know. So even with high volume of writes, they can use Datomic.
So just to clarify, does Datomic run as a separate process on some server, or is it implemented as a library that you use from your application code?
It's a Java process, transactor in this case.
What does operations have to care about when you run Datomic? I would expect you to worry about what mechanisms it uses, the RAG databases, the SQL databases, some other or data or processes, or what does operations have to take care about?
Datomic provides a lot of configuration. The default configuration is pretty good, so most of the time you don't have to change your configuration except of providing path to your database storage. So if you use DynamoDB, you would use key. You can also increase caching of the RAM for your transactions, for your transactor. So it's possible to tweak Datomic, but the default configurations are pretty convenient and sensible. Any other questions? Yeah.
To add to his point, then I have to worry about scaling my storage layer as well as Datomic. So I have now two scaling problems. I mean, is that correct?
Yeah, depending on your needs, yes, it would be. But storage is quite, it's inexpensive. Using DynamoDB, you can store a lot of data. And again, Datomic is not bulletproof and doesn't answer everything. So you have to assess it if you need unlimited writes, then probably Datomic will be the best option. But if you've got a lot of applications that use the same database, don't have crazy amount of writes, and some benefits of Datomic like fairly easy querying and going to fast,